First of all, I want to thank Ben-Gurion University for awarding me the professorship. I'm not a professor yet, but it's okay. It's nice to see. I didn't notice it before. I just went over the abstract, but I didn't notice the professorship. And I actually, I asked Idan to rearrange the talk order because I was never fortunate enough to be scheduled before lunch and to say this famous sentence, I'm the only one between you and lunch break. So here I get to say it. I promise to be very nice. And so, you know, for this audience, I put this slide to say I'm not sure it's a very famous saying, but I like it anyway. You don't have to tell Noah about the flood, so I don't have to tell you, I guess, about autism, the rates of autism. So I'm going to skip all of that. You know, the numbers are going up steadily. That are just partially explained by changes in diagnosis and more awareness and so on. Rates in Israel go up. Several studies have shown that also. And there are quite many unknown environmental and epigenetic factors. Not everything is genetic in autism. And so, moving fast forward, this is a slide by a colleague at Columbia University, Mary Hornig, describing what she calls the 3 strikes model, genes, environmental, epigenetic factors, and the third strike is the timing. So we know the critical times of brain development and trajectory could go in different ways based not only on the genetic makeup, on the environmental insult, but also on the time. And we're talking about really narrow windows, sometimes a matter of weeks. And there are quite a few studies and meta-analysis and umbrella meta-analysis describing a variety of environmental or non-genetic risk factors. And I'm sure some of them have been mentioned here earlier today. And I'm going to lay out the general concept and then talk about the methods really briefly and then take you right to the results and then we can go out for lunch. So the general idea was, assuming there is a rise in the true incidence of autism, what has changed in the way kids are brought into the world, assuming the pre- and perinatal factors might be involved in that risk for autism. And so parents' age has been mentioned in the last talk and maybe previous talks, the father's age, which we described back in 2006 using the Israeli Drakbo data and has been replicated since many times. And then maternal age also has an effect, even not as much as the father's age. The other example might be caesarean section, the higher rates of caesarean section, and we and others have shown an association, not necessarily causal, between C-section and risk of autism. And another thing that has definitely happened is that children that were born prematurely and at low birth weight survive today more thanks to NICUs and development in technology, and perhaps those children born early or at small birth weight or at high risk for autism. The major strength of our study is that we were able to put together what we call a mega cohort, a cohort of cohorts, 6 data contributing countries, altogether 4 Scandinavians, West Australia, and Israel. The first grant was called iCare, and now the newer and more multi-generational cohort is called Minerva, and the data comes from that cohort, and again, the strength is the very large numbers. So we're protected by the law of large numbers. If there is misclassification of either the exposure, in our case, birth weight or birth week, and in the outcome, autism, especially the highly functioning, the children in the broad autism phenotype might be misclassified. When you have very large numbers, the effect of this classifications is diluted, and the results should be pretty robust. So I mentioned the NICUs and the fact that children survive, or newborns survive better today. I'm going to skip this, but generally this is showing Israeli data and also latest some US data that the prevalence, a slide that shows US data showing the increase in preterm birth. Again, the increase is not very steep, but assuming this is not a rare event, the numbers are big. And so the study population for this analysis included the Scandinavian data only, those years. And this is the distribution of birth weeks. You can, I just gave you the numbers here, not the proportions, but you can see that we have robust enough numbers to conduct analysis. We have a lot of statistical power here, and we estimated the relative risks in adjusting for site, for country, for birth year, and for maternal age. It's pretty difficult to see it here, but if you can see the reference group, I don't know if I have a pointer here, but the reference group are full-term babies, and you can see the increase in risk for preterm and also for post-term babies, and you can see I'll read it to you, it's the relative risk is 216 for the earlier birth, and then it goes to 125 for those closer to full term. So there is what we call sometimes in epidemiology a dose-response relationship. The higher the dose of the risk, the higher is the risk of the outcome. And I think it'll be easier and also faster to see it graphically. So here we have a state by state, country by country actually, Finland, Sweden, and Norway. And I'll take you straight to the plot that combines those three countries. And you can see the increase in risk preterm and also sometimes somewhat in post-term babies. And you can see the confidence interval around it. And all of those findings are statistically significant. As you've seen, the relative risk, especially for the those born really early, robust and presumably will withstand adjusting for confounders that we didn't measure or measured incorrectly. So this summarizes the data in a different way, and you can see the relative risk for ASD by sex and gestational age compared to week 14, which is the reference group of 1, the null. And then we were trying to see if gestational age has an effect, and we saw that also when stratifying on size for gestational age, the results, they vary, but they remain pretty robust, statistically significant across the size, small and large, and appropriate for gestational age, as well as in males and females. So I know I've rushed it real quickly. I just want to, before I show you the Happy Lab photo, I want to say that the nature of observational studies is that we are always aware and must mention those confounders, those factors that might be related to the exposure at hand, which is the early birth, as well as to autism. We could not address for a variety of confounders, so we don't try to claim this is a causal relationship by any way, but we do say this is a risk indicator, and I'm sorry I mislead this talk, but I'm sure when we try to build a predictive model for children that are at risk, for autism, especially if there's the other risk factors, known risk factors such as family history, or maybe advanced paternal and maternal age. This could be a risk indicator. So this is a Happy Lab photo from earlier meetings. They always took place in the winter in Stockholm, Sweden, and then at Karolinska Institute, and then one or two of you might have heard that already. I went to the Nobel Forum, and I knew that that's as close as I'm going to get to this. So because I don't do this, and so I want to say thank you for inviting an epidemiologist, and I hope that I rushed it in a way that was still comprehensible, but would let you go out in time. If there are any questions, I'm happy to answer down here.